There are three main ideas to keep in mind when you're solving any kind of equation. The first thing is to isolate. You need to isolate the variable, and that means you want to get the variable all alone on one side of the equation so that your final answer will look something like this. It'll say like x equals and then a number over here. So x all by itself, when you have the variable all alone, we say we've isolated it. The next thing that you need to keep in mind is an inverse operation. An inverse operation is the opposite operation. And every time you solve an equation, you're going to use the inverse operation to do so. So if you have an addition problem, you're going to use subtraction to solve it. And if you have a subtraction equation, you'll use addition to solve it. If you have a multiplication equation, you use division to solve it. And if you have a division equation, you use multiplication. So whatever operation the problem has, you're going to do the opposite operation to solve it. And then the third thing to keep in mind is to balance. You have to balance an equation, which means it's okay to change an equation as long as you change both sides of the equal sign the same way, and that will help keep things balanced. Okay, now here's an example of an addition equation. So this says 5 plus m equals 8. What we want to do to solve this equation is figure out what m could be. When we solve it, it means we find the value of m that will make this equation correct. Now, I'm going to show you with pictures what we're going to do, and then I'll show you mathematically how you show this. If I want to isolate my variable, that means I want to get m all by itself. So what I need to do to get m by itself is I need to take away all these other numbers on this side. I want to take them away. But if I take away a number on this side, then I also have to take one away on the other side. Just one. Okay? And I can keep doing that where I take one away from the left and one away from the right until I've got that variable isolated. And once I've done that and I have that variable all by itself, there's nothing else to take away, I can see my answer. I see that m equals 3. Now let me show you mathematically what we did. Okay? Think about this for a second. Right here, I have 5. I want to take all 5 of these away so that m is all by itself. So if you look at the way your problem is written down here, I said I want to take away 5. So what I'm going to do down here mathematically is show I'm taking away 5. So I'm going to take away these 5 things up here. Now, if I take away 5 on this side, I also have to take away 5 over here. So I'm going to take away these 5. And the way I show that is I subtract over here. So remember, here's some things to think about. In order to keep it balanced, whatever I did on one side, I had to do on the other side. And then we also talked about isolating the variable. That's getting this variable by itself. And the other thing is we said you need to use your inverse operation. This is a positive 5. It's like we're adding 5. So the opposite of that is subtracting 5. Now if I have 5 minus 5, that equals 0. So those two numbers are going to cancel out. And on this side I'm left with m. All by itself, that's my isolated variable. And 8 minus 5 is 3. So we get that m equals 3. Now it's really important when you solve equations that you check your work. And what you do to check your work is you start off with your original equation, and then you're going to substitute your value for m into your equation, and you're just going to double check that it works. 5 plus 3 is 8, which is what we wanted it to be. So we say that's checks. Let's look at another one. We're going to do this one just mathematically. This is an addition equation. Okay, so we have 12 plus x equals 38. So what I need to do to isolate this variable is I need to make this, get rid of this. So if this is 12, the way I'm going to get rid of it is I'm going to subtract 12. And to keep this equation balanced, if I subtract 12 there, I'm going to subtract 12 here. Now my two 12s, 12 minus 12, cancel out. So I've got my x all by itself over here isolated. And if I do 38 minus 12, that gives me 26. So to solve this equation, x equals 26. Now to check it, go back to your original equation. 12 plus x equals 38. Then we're going to substitute in for a value of x. So we get 12 plus 26 equals 38. And 12 plus 26 is 38. So 38 does equal 38, so it checks out. Now, the problems can be done with fractions and decimals also. You follow the exact same process. So a plus 3.9 equals 16.3. To isolate that variable, I'm going to do the opposite of adding 3.9, which is subtracting 3.9. And I'll do that on both sides, which means these two numbers cancel out, and I'm going to be left with a equals 12.4. Now, you might not be able to subtract that in your head, and that's okay. All you need to do is show your work. We're going to regroup this. 13 take away 9 is 4. 5 take away 3 is 2. And 1 take away 0 is 1. So we get 12.4. So now to check my work, back to our original equation. And then I'm going to do my substitution. I'm going to take that 12.4 and plug it in for a. So I have 12.4 plus 3.9. Hopefully that equals 16.3. And again, if you can't do this in your head, that's totally fine. Just go off to the side. 4 and 9 is 13. 1 plus 2 plus 3 is 6. And then my little decimal point. So it does equal 16.3, which is what we wanted it to equal. So this problem checks as well.